In this video, let us solve the problems of section E. First, let us solve the 36th question. The question is, Mrs. Sheela visited a store near the house and found that the glass jars are arranged one above the other in a specific pattern. On the top layer there are 3 jars, and in the next layer there are 6 jars, and in the third layer from the top there are 9 jars, and so on till the 8th layer. On the basis of the above situation, answer the following questions. The first one, write the AP whose terms represent the number of jars in different layers starting from the top. Also find common difference. The second one is it possible to arrange 34 jars in a layer if the pattern is continued? Justify your answer. Third, A. If there are n number of rows in a layer, then find the expression for finding total number of jars in terms of n. Hence find as 8. Third, B. The shopkeeper added 3 jars in each layer. How many jars are there in 5th layer from the top? Now let us solve the first one. Pattern of numbers of jars in each layer forms an arithmetic progression. Here, the first term A is 3 because on the top layer there are 3 jars. Second term, that is A2, is 6. The third term A3, that is 9. So here common difference, D is equal to A2 minus A, that is 6 minus 3, that is equal to 3, or A3 minus A2, 9 minus 6, that is equal to 3. And we are also asked us to write AP. First term is 3, common difference is 3. 3 plus 3, 6, 6 plus 3, 9, 9 plus 3, 12, 12 plus 3, 15, so on up to 8th layer, 3 8s are 24. Okay, on the 8th layer there will be 24 jars. The next question, checking for 34 jars in a layer. For that, AN is equal to A plus N minus 1 into D. That is the general term of the progression. We have to use that formula. To see if 34 jars can fit into a layer, we need to find if 34 can be a term in the AP. For that, you have to use the general form of nth term of an AP, which is equal to AN is equal to A plus N minus 1 into D. Plugging the values. Here AN, nth term is 34, A is 3, N minus 1, we don't know N, we have to find out. Common difference is 3. Now let us transpose 3 to this side. Now what happens? N minus 1 into 3 is equal to 34 minus 3, that is 31. Now let us shift 3 to this side. 31 by 3. N minus 1 is equal to 31 by 3. It is not a whole number, it is a fraction. Since n minus 1 is not an integer, n is also not an integer. Since n is not an integer, it is not possible to have exactly 34 jars in any layer. Third A, total number of jars in n layers. We know that sum of first n terms of an AP is Sn is equal to n by 2 into 2A plus n minus 1 into D. Now we have to derive an expression for n layers of jars. For A is equal to 3, D is equal to 3, N is equal to N. So Sn is equal to N by 2, A is 3 and D is 3. Substitute. So Sn is equal to N by 2 into 3 is 6, 3N into 3. So 6 minus 3 is 3. So Sn is equal to N by 2 into 3 plus 3N. Now multiply these things, these two. Sn is equal to 3N square into 3N plus 3N by 2. Now for 8 layers, total number of jars, that means N is equal to 8. 3 into 8 square plus 3 into 8 by 2. 3 into 64 plus 3 into 8 by 2. 3 into 64 is 192. 3 into 8 is 24. 192 plus 24 is equal to 216 by 2. That is equal to 2 ones are zeros are 8s are. So S8 is equal to 108. So for 8 layers, the total number of jars is 108. Adding 3 jars in each layer. Here first term. The new first term. What is? 3 plus 3, that is 6. Let it be A dash. A dash is equal to 6. Common difference will be 3 only. General form of nth term of AP is equal to AN is equal to A plus N minus 1 into D. Plugging the values. We have to find the number of jars in 5th layer. So A5 is equal to A is 6, N is 5, D is 3. A5 is equal to 6 plus 4 into 3. A5 is equal to 6 plus 12. So 5th term A5 is equal to 6 plus 12, that is 18. So 5th layer will have 18 jars. I hope you have understood the problem. Please like, share and subscribe. Now let us solve the question number 37 from section E. The question is, triangle is very popular shape used in interior designing. The picture given above shows the cabinet designed by famous interior designer. Here the largest triangle is represented by triangle ABC and the smallest one with shelf is represented by triangle DEF. PQ is parallel to EF. Show that triangle DPQ is similar to triangle DEF. The second one, if DP is 50 cm and PE is 70 cm, then find PQ by EF. The third one, there are two choices. The first choice is if 2AB is equal to 5DE and triangle ABC is similar to triangle DEF, then show that perimeter of triangle ABC upon perimeter of triangle DEF is constant. Or the second choice, if AM and DN are the medians of triangles ABC and DEF respectively, then prove that triangle ABM is similar to triangle DEN. Now let us solve the first one. Prove that triangle DPQ is similar to triangle DEF. Let us have the figure. Let us compare the given triangles, triangle DPQ and triangle DEF. Here we have PQ parallel to EF. So what happens? Corresponding angles are equal, isn't it? So angle P is equal to angle Q. Angle DPQ is equal to angle DEF because they are corresponding angles. Similarly, angle Q is equal to angle F. Angle DQP is equal to angle DFE, corresponding angles. Angle D is common to both. Angle PDQ is equal to angle EDF, common angles. Therefore, by angle similarity criterion, this angle, one angle, angle. Similarity criterion, we get triangle DPQ is similar to triangle DEF. Hence proved. Second one, find the value of PQ by EF. We just proved that triangle DPQ is similar to triangle DEF. So ratio of their corresponding sides are in proportion. So PQ by EF is equal to DP by DE. PQ by EF is equal to DP is 50. DE is 50 plus 70. So PQ by EF is equal to 50 by 120. Here 0 and 0 get cancels. So PQ by EF is equal to 5 by 12. Third A, perimeter of triangle ABC upon perimeter of triangle DEF is a constant, we have to prove. Given that triangle ABC is similar to triangle DEF, so AB by DE is equal to AC by DF is equal to BC by EF. Why? In similar triangles, ratio of the corresponding sides are in proportion. It is also given that 2AB is equal to 5DE. So AB by DE is equal to 5 by 2. AB by DE is equal to 5 by 2. So AB by DE is equal to AC by DF is equal to BC by EF is equal to 5 by 2. So AB is equal to transpose DE to this side, 5 by 2 DE. Similarly, AC is equal to 5 by 2 DF. Similarly, BC is equal to 5 by 2 EF. Now let us find the value of perimeter of triangle ABC upon perimeter of triangle DEF. We know that perimeter of a triangle is equal to sum of all the sides. So perimeter of triangle ABC is equal to AB plus BC plus CA. Perimeter of triangle DEF is equal to DE plus EF plus FD. But we know that AB is equal to 5 by 2 DE, AC is equal to 5 by 2 DF, BC is equal to 5 by 2 EF. So now let us write instead of AB 5 by 2 DE like that. Instead of BC 5 by 2 EF, instead of CA let us write 5 by 2 DF. Here 5 by 2 is common. Let us take it outside the bracket. So inside the bracket DE plus EF plus DF. Here you can observe that this and this are same things, so we can cancel them. So perimeter of triangle ABC upon perimeter of triangle DEF is, so perimeter of triangle ABC upon perimeter of triangle DEF is equal to 5 by 2, which is a constant. So perimeter of triangle ABC upon perimeter of triangle DEF is a constant. Now let us solve the third B question. If AM and DN are the medians of triangle ABC and triangle DEF respectively, prove that triangle ABM is similar to triangle DEN. Let us have the triangles ABC and DEF. Now let us draw medians to the triangles. Draw AM median to triangle ABC. Here AM is the median and bisects BC. That means BM is equal to MC. Or we can also say that BC is equal to 2BM. Now let us draw DN median to triangle DEF. It bisects EF so that EN is equal to NF or EF is equal to 2EN. We are given that triangle ABC is similar to triangle DEF. So AB by DE is equal to BC by EF. In these triangles, we have to compare ABM and DEN. So, AB by DE is equal to BC by EF. But what is BC? Instead of BC, we can write 2BM. Instead of EF, we can write 2EN. Here 2 and 2 get cancels. So AB by DE is equal to BM by EN. Side we have proved. We know that angle B is equal to angle E. Why? Triangle ABC is similar to triangle DEF. The corresponding angles are equal. So, side, angle, side criterion. So, according to side, angle, side criterion, similarity criterion, triangle ABC is similar to triangle DEN. Hence proved. Please do press like button if you liked the solution. Now let us solve 38th question of section E. The question is, metallic silos are used by farmers for storing grains. Farmer Girdhar has decided to build a new metallic silo to store his harvested grains. It is in the shape of cylinder mounted by a cone. Dimensions of the conical part of a silo is as follows. Radius of the base is 1.5 meter, height is 2 meter. Dimensions of cylindrical part of a silo is as follows. Radius is 1.5 meter, height is 7 meter. On the basis of the above information, answer the following questions. Calculate the slant height of the conical part of one silo. This is the first question. The second question is find the curved surface area of the conical part of one silo. The third question has two internal choices. The first among this is find the cost of metal sheet used to make the curved cylindrical part of one silo at the rate of rupees 2000 per meter square. Or second choice is find the total capacity of one silo to store grains. Now let us draw a diagram to better understand the question. This is the figure of silo. Here radius of cylindrical part as well as conical part is 1.5 meter. Height of conical part is 2 meter. Height of cylindrical part is 7 meter. The first question is we have to find the slant height of the conical part. We know that slant height L is equal to square root of R square plus H square. Now let us substitute the values. Here radius is 1.5 meter, H is 2 meter. We have to find slant height. L is equal to square root of 1.5 square plus 2 square. 1.5 square is 2.25. 2 square is 4. So L is equal to square root of 2.25 plus 4, which is equal to square root of 6.25. So L is equal to 2.5 meter. Slant height L is equal to 2.5 meter. Therefore, slant height of the conical part is 2.5 meter. We have to find the curved surface area of the conical part. We know that curved surface area A is equal to pi RL. Here pi is 22/7, R is 1.5, L is 2.5. This is 1.5, this is 2.5. 1.5 into 2.5 is 3.75. So A is equal to 11.79 meter square. Therefore, curved surface area of the conical part is 11.79 meter square. Now let us solve third question. The first choice, we have to find the cost of metal sheet for cylindrical part. This is cylindrical part, height of which is 7 meter, radius is 1.5 meter. We know that curved surface area of the cylindrical part is 2 pi r h. Now let us substitute the values. R is 1.5, height is 7. Here 7 and 7 get cancels. So A is equal to 2 into 22 is 44 into 1.5. So this is equal to 66 meter square. Now the cost of 1 meter square metal is rupees 2000. Hence cost of 66 meter square is equal to 66 into 2000. That is equal to 1,32,000. Therefore, cost of metal used to make curved surface area of cylindrical part is 1,32,000 rupees. Now let us solve the second choice question. Find the total capacity of one silo to store grains. Full. So total capacity is equal to volume of cylindrical part, this part, and volume of conical part, this part. Volume of cylinder is equal to pi r square h, because we have kept this as h, plus volume of conical part is 1/3 pi r square h. Now here pi r square is common, h plus 1/3 h. Don't add these two, they are different things. Now let us substitute the values. 22/7, radius is 1.5 into h is 7 plus 1/3 h. This is 2. Here if we add these two, this becomes 2/3 plus 7. LCM is 3. So this is 21/3. So it is 21 plus 2, 23 by 3. Here 3 ones are 3, 0.5s are. Here we have 1.5, 0.5 into 1.5. So this is equal to, if we multiply these two, we will get 0.75 into 3. That is equal to 54.21. So therefore total capacity of 1 silo is 54.21 meter cube.